So today is something that is different. We haven't learned this yet. We didn't talk about this in Algebra 1 at all. It's called synthetic division. If we had extra time or if I felt it was necessary, there's synthetic division, and then there's also a way to divide polynomials called long division. Long division is way more useful because you can divide any polynomials by any polynomials. Synthetic division, you can only divide whatever polynomial by a binomial. So that restricts it a little bit. But synthetic division is a lot quicker. I would say it's a lot easier. Perfect world, I'd have enough time to go over both of them, and it'd be a great time. But probably lucky for you guys, we're just going to do synthetic division. Yeah, so synthetic division only works when you're dividing by a linear equation, which is for the most part a binomial. The other option is long division. I thought about showing you a long division one just because it is kind of interesting. In my opinion, the most interesting part is how similar it is to when you did long division back like in elementary school. But again, I don't necessarily need to waste a lot of time on that. So we will get into this, or I guess I should say, so when I was trying to figure out how to teach this, in my opinion, this is one of those things that is more so than usual. I don't think synthetic division is that hard, especially because we're just barely scratching the surface. I don't think it's that bad, but it's brand new and it's kind of confusing what is happening. And so I found, in my opinion, the easiest way is to show you this is what we're eventually going to set up. So really, we have that little 5 in the box, then we have those numbers, then there's a line, and then make it 45. I'll talk to you about where we're getting those numbers, how we're getting those numbers. I'll do that in a second. But I think it helps students to see the pattern and to realize how we do synthetic division before we learn how to set it up, or before we learn how to put it in this format. Because really, in my opinion, putting it in this format's not terrible. There's a couple things to remember. And then once it's in here, it's not terrible. But again, I found where some students, when you try to do all of it, they kind of forget which one is which. And so I think this is going to be a little bit easier to follow. This is how to set up synthetic division. We will get these numbers right here, the top numbers, from your polynomial. This number is going to be for your factor or your zero or something like that. We'll talk about it in a second. And we're going to write numbers in this blank area, so make sure you leave enough space for that. And then we'll have some other numbers we'll write down here at the bottom. So the first step, and I would argue the hardest step because you only do it once. And when I say hardest, it's just the hardest to remember. That number, whatever that number is, all you do is drop it straight down. So that 1 literally just goes straight down as a 1. That's it. Now, once you have that, you start going into this pattern where you're going to do a loop over and over and over again. This second one I wrote down here, it's really long, but the reason I did that is because I do that loop over and over and over, and you kind of see that loop a little bit better when you do a lot longer of a problem. So we won't have any that are that long, but again, it's not any harder, it just takes a little longer because it's the same loop. So you take that 5, multiply it by whatever number you have down here. So 5 times 1 is 5. That number goes up here with my 7. So that's the first step in your loop. Whatever that number is in the box gets multiplied by that number in the bottom, and that goes up below whatever that next number is. The second step to our loop is now we add those two together. So negative 7 plus 5 is negative 2. Now that's the loop that we do over and over again. So just like we took 5 times 1, now we take 5 times negative 2. 5 times negative 10, that goes up under that next column. Then once we have that, we add those together. Now just keep in mind, adding these together isn't a nightmare by any means, but there are positives and negatives that sometimes you have to be a little bit aware of. So just be careful, especially if there's negatives. But 14 plus negative 10 is positive 4. 5 times 4 is 8. Negative 11 plus 20 is 9. Times 9 is positive 45. Add those together, you end up getting 0. Now, for our purposes today, we're always going to get 0. Tomorrow, I think I peppered in, actually took out tomorrow, and I took those out because who likes fractions. But I peppered in some, have the number there. That's the remainder. Remember back when you guys were doing division when it was like 56 divided by, and you got the remainder. That's what the number is going to go in. 0 would be remainder. For our purposes, we're never going to have a remainder. Perfect factors. Factors divide evenly with no remainder. You really need to know that, but interesting stuff you'll probably post about on your Insta chat later. That's it. And there's one other step to get it in. We put it in of memorization goes where, and it's really not too bad. That's the thing. I don't think this is too bad. I can't tell you that when, but I can also tell you I vividly remember I was 6 in school, and so it was very difficult to figure out what was going on. It's okay though. I learned about it later. Yesterday, I figured it out. So moving on to the next one. Again, this is not anything different. It's not the number we have up there in the box, and I'll talk to you about how we get that number here not too long. But the number that is up in the box is a negative, not any different. Again, the hardest part, and the reason it ends up being the hardest part, or I guess I should say commonly is because for a lot of people, I don't know what the negative what the thing is or what they get confused with. A lot of people forget the first step, they just bring that number straight down every single time. Start that loop. Times 9 is negative 18. Negative 12 minus 18 is negative 30. I think. And negative 30 is positive 60. Negative 3 plus 60 is negative 3. Add those together. Is positive 6. Negative 2 times 99. 198. Or I should say 66 plus negative 198. Not that it actually matters. Weird numbers that are a little bit bigger. Again, calculator. It's not the end of the world. Negative 2 times negative 32. Positive 260. 45. And continue this loop. Negative 2 times 45 is negative 90. Is negative 66. Do 20 minus 90, that's fine. But again, I want to drill in your head that you add every time, because if you start looking at subtraction, it gets a little bit confusing with negatives. So negative 90 is how I always say it. Times negative 2. 2. Positive 132. Add those together. Negative 2 times 24 is negative 48. That ends up giving you 0. Again, for today, that's a really good way to make sure you're on the right track if you get a 0 there. Now, again, tomorrow we'll talk about if you don't get a 0, if you get a remainder on the quiz, or I guess probably won't have a quiz over this. But on the test, probably one of them you end up with a remainder. I don't really remember. But for the most part, you should end up getting 0 for that. So when you take the test, if every single one of them you have a remainder, you probably should double check that. So I was double checking how I should ask that question, if I should give you more help on the test. Any questions on that so far? Now, again, we have to learn how to put it in this format. But once you have in this format, that's the new stuff. That's the part of today. That's the actually, honestly, that's the math part. Everything else is just knowing where to put the numbers and copy things down. Like, for instance, the way this would look, let's see, this is x 2, 3, 4, 5, 6, 7, 8. So this represents 9x to the 8th power minus 12x to the 7th minus 63x to the 6th plus 93x to the 5th plus 66x to the 4th minus 219x to the 3rd plus 24x squared minus 108x plus 48 divided by x plus 2. That's what that would represent. That sounds super complicated, but if we're being honest, I did that in my head, so it's not hard at all. Okay, so before we get into that, real quick, I want to make sure you know how to find the zeros. Now, we talked about this before, where and I briefly mentioned this, but zeros are the same thing as solutions. Remember when we graph quadratics, wherever they cross the intercepts, the x-axis, those were the solutions. Also called zeros because that's where the y value is zero. So that is where they get the term zeros. But really, we're just solving these. So what is the 0 by x minus 5? The 0 is just 5 to 5. So here, if you imagine that being equal to 0, again, that's why they're called zeros. 5. Next one. That is negative 6. Again, you need to put it equal to 0, subtract 6 from both sides. That's what we get for the 0. Now, be careful, because a lot of students look at this and they say, oh, that's easy. It's just the opposite of what it looks. Minus 5, you get a positive 5. Plus 6 is a negative 6. It's just the opposite. Now, you're absolutely right for the most part, but then they'll throw in one like number 3 where it's x is equal to 4, and a lot of people will put negative 4. No, that is the 0. It's already solved. It's already equal, so that is the 0. That's the solution. Same thing, the next one, already solved for you. Just so that is something. And if you look down below, there's some that say that where they have the binomial where you'll have to solve and find the 0. Number 2, they'll have it where they give it to you where x is equal to something, so they already have it solved for you. The last one, and this is an example of the problems I ended up actually taking off. But this one, just to see what that is, because it is good practice. Again, if you need to set it equal to 0, subtract 2, 3x is equal to negative 2, divided by 3. We get x is equal to negative 2 over 3. Now, again, one of the things that hopefully is a little bit light bulb or something that you think of when you see this is when we did solving by factoring. Remember when we did solving by factoring, we would factor it, we'd get 2 binomials, and we'd set each one equal to 0 and solve. Again, that's kind of essentially what we're doing, and those are the zeros. Which, speaking of, tomorrow we're going to do factoring, so get ready to live. Now, all of a sudden, after I say that, you're like, oh man, I hope we don't have a snow day tomorrow. Because I know you guys have all heard about the weather. But don't ask me because I don't watch the weather. Okay. Finding the zero, obviously very essential part. Maybe you take that what I said, or maybe that's another math part. Hopefully not difficult, but. So now let's get into how to set up the synthetic division. So eventually you'll be able to use synthetic division. I mean, you really get into it. It must have been pre-calculus. It has been so long since I've taken some of these classes that when I was planning this, I was like, man, when I was in school, we used synthetic division to factor, to find all the possible zeros, to graph, and then it dawned on me, I think that was probably pre-calculus, but it would have had to been. So we're not solving anything. We're not doing any factoring. That doesn't mean anything to you, but apparently I thought it was important to put up there, and I don't proofread super closely. Number 1, we are taking this big polynomial and by x minus 4, the binomial. So this is how you're going to set this up. First, we need to know what 0 is. If they don't tell us a 0, we need to find a 0. So x minus 4 means our 0 is going to be positive 4. And again, it's for the same exact reason we just talked about. If you want to set it equal to 0 and solve, you can. You do not need to do that in this chapter. I don't mind. That number is the one that goes in the little box. So when we use division, we have this little box. That number goes up there. The important thing with that number, you guys probably would understand or would guess this, but the thing that a lot of people miss is a lot of people put negative 4. So double check that because that's a pretty common mistake. I use a multiple choice. First mistake I put on there that I try to I put a negative 1. So, then the rest of them are all the coefficients. What you put here is 1, -7, 2, 45, -20. The only thing you have to be careful of is every. So whatever your first the 4 or the 3 or the 2, whatever that first one is, you write down. And then every other exponent needs something there. So we have a 3, 2, and 1, so we're good. If they ever skip one of these, if they didn't have the 3, you need to put a 0 there. We'll talk about that in a little bit, but that's the only tricky part about, in my opinion, that's the only tricky part about synthetic division, making sure you realize, oh, they skipped a number, so I need to put a 0 in there kind of as a placeholder. But we don't have that, so we have 1, x to the 4. The next coefficient is -7. The next one's +2, 45, and -20. That, to put that into synthetic division, you just draw a straight up and down line between the last 2 numbers, which would be kind of essentially you're cutting off the constant, the one that doesn't have a variable. And again, you draw the line down here, but make sure you leave enough room that you can add some numbers in there. Students, that first thing we draw here, obviously that's not going to be super easy to work with. Now, some of you guys, a lot of you guys are probably ahead of me because now you know how to set it up, and now we solve it just like we did before. Step 1 is the one that people forget, is just dropping out one as if it was hot, some would say. That's maybe not. So you take the 4 times the 1, it's 4. 7 plus 4. If you use a calculator, please use one. I know some people don't use one because they're embarrassed to use a calculator on a quote-unquote easy problem. But here's the deal. In my opinion, it's more embarrassing to get a problem wrong when you could have used a calculator. That said, you should obviously be embarrassed in this class at all. So now we have that -3. Take -3 times 4 is -12. That goes up to the next spot. Add those together. Same thing every time. 10 is -40. Add those together. 4 times +20. Add those together, you get 0. Now again, for today, you'll get 0. Pondering, I haven't decided to change it on the test. On the test where there is one with a remainder, I thought about putting in the instructions something along the lines of they're not perfect factors, or x minus 4 is not a factor of this polynomial. Because again, if you get a remainder of 0, that means x minus 4 was a factor. If it wasn't, you get 0, you get a remainder. So I might do that to give you a little bit of a hint that there is a remainder on some of them. But for today, you won't ever have a remainder, it'll always be 0. Because it's a really nice way to check your work if you know you get 0, it does work out. It's very satisfying. Okay, last but not least, what does that mean? So yes, we got 1, -3, -10, 5. What do we? So that's the answer. You just get a bunch of numbers. Now again, that's not your answer, but if you look back at what we're actually trying to find, we are taking this polynomial divided by this binomial. What does that leave us with? Well, it leaves us with this string of numbers. We turn this into something we can use is each one of these goes with one of your exponents. So remember what I said earlier when you wrote these down? A 1 is a coefficient, the next exponent needs something. The only thing you have to remember with this part is that this number is now your constant. So we got a 0 in this part. This was our constant. The whole reason we bracket that off is because now with our answer, that's our new constant, and then it just goes in order. This is your constant, x to the first power, x to the second, x to the third, x to the fourth, x to the fifth, so on and so forth. So I'm going ahead and labeling. This is my constant, this is my x to the first, or just x, this is my x squared, this is my x to the third. So your final answer is 1x to the third. x squared 10x plus 5. So if you take minus 7x to the third plus 2x squared plus 45x minus 20, divide that by x minus 4, you end up getting the answer x to the third minus 3x squared minus 10x plus 5. Now again, there's a lot of cool things you can do with that. Tomorrow we'll learn how to solve and find all of our zeros with this. Not today. That would be a nightmare. In that polynomial. And again, the thing that students miss a lot on this one is the fact that that 5, whatever's in that spot, is the constant with no x. A lot of students think that it starts with x to the first. I mean, I guess essentially you could think of it as you start with 0, x to the 0, x to the first, x to the second. If that resonates at all, you can think of it that way. Any questions on that one? Because now after that, it should pick up a little bit, go a little bit quicker. Now, number 2, the good news is they tell you what the 0 is. So again, with this one, make sure you're not falling into the habit of saying, oh, well, it's a -1, so in my box is a +1. No, that's only if they don't solve. If they give you the binomial, if they give you the 2 terms, x is equal to solve. But if they tell you x is equal to, they're giving you that step. So that's just +2, -1, -2. Again, all of your exponents are taken care of. 3, 2, 1, 0. And set of your synthetic division. Your 1 drops down. -1 times 1 is -1. 2 minus 1 is +1. Again, just be careful with positives and negatives. 1, add those together, -2. A lot of people put 0 for that. 2 is +2. That ends up giving you a remainder of 0. That's what we want. So you don't have to do this part, but it does help a lot of students. This is your constant, or x to the 0, x to the first, x squared. 1x squared, x minus 2. Now tomorrow what we're going to do then is when we finally get to this part, we'll take what's left and we'll factor that. Tomorrow. That's all there is to synthetic division. Okay. Number 3 and 4. This is the only thing that, in my opinion, this is the only thing that's hard with synthetic division. It's the hardest part, and it's hard because it's not actually at all. It's just hard to remember. So notice on number 3, we have x to the third, we have x squared, and then we have -19x. The only thing you have to remember is that essentially you need to add, if we have x to the third, we need to add a 0x squared. Again, every exponent needs accounted for. 0x to the fourth. Wherever you're starting, that's your start. You need an exponent for everything after that. So if we have x to the third, we need an x squared, we need an x. If we have an x to the fifth, we need x to the fifth, x to the second, x to the first. Every exponent needs accounted for, including your constant, which doesn't really ever happen. Now, again, obviously, you do not have to rewrite it if you don't want to, but for today, for our purpose, I'm going to. I tell you that this is a factor, so this one even looks different than what we did for number 1. Number 1, they showed it as a division problem. This one, they're just telling you that that's a factor. By the way, again, if they tell you, and maybe this is how I'll word it on the test, if they tell you it's a factor, that means it's got a remainder of 0. That's what I've been telling you. That's the whole idea of a factor. 8 is a factor of 56 because 56 divided by 8 does not give you a remainder. So maybe that's how it'll work. That's not a bad idea. What x is equal to, we need to find our 0 first, because they don't tell you. They'll tell you what x is equal to. If not, we need to find it. So that goes in your your box. X to the third, a 0x squared. Obviously, that's the biggest mistake. A lot of people don't even think about it, and they just move on to the negative 19. So make sure that's not you. Setup, once you do have it set up, it's the same as every other division. Drop the 1 straight down. 2 times 1 is 2. 2 is 2. 2 is 4. Negative 19 plus 4 is negative 15. 2 times negative 15 is 30. That does give you 0, which again makes sense because it is a factor. And just like we said before, that means we have a constant, our x and our x squared. So we have 1x squared plus 2x minus 15. Placeholder, putting in that. Okay. Last one little for you guys. This one has a leading coefficient of 2. That doesn't make any difference to us. We're adding 2. But again, hopefully this is more obvious that we don't have an x squared. We don't have an x. We're missing a lot of exponents in this. So again, you don't have to do this, but it's not a bad idea to rewrite it. That's 2x to the third plus 0x squared. So we didn't have an x squared. Plus 0x. So we didn't have x. And then we have the 2. Tell us what this is equal to. So that's going to be negative 5. So that's what goes in the box. I mean, it's the same as what we've been doing. 2, 0, 0. And then we saw what we've been doing. The 2 drops straight down. Negative 5 times 2 is negative 10. 0 plus negative 10 is just negative 10. It's not rocket surgery. Negative 10 is positive 50. Mm. 0 plus positive 50 is positive 50. Negative 5 times 50 is negative 250, which is what I was interested in. So this one, I said this didn't happen, but apparently it happens once. I'll probably change this. But that does give you a remainder of 1. We're not going to worry about that right now. I think that was a mistype, which is interesting. I wonder if that's what you guys get under you do. Ignore this 1 for right now. So this would be 2x squared minus 10x plus 50. We will talk about what to do with that one later. So again, technically, this is not actually the right answer to this one. I'm not about to like more in depth with this. Something to look forward to. Are there any questions on these? Okay. We have about 15 minutes left. So for what it's worth, number 6 does not have any remainder, like it should be. But that's just number 6, yeah. I would say actually, if I were exit ticket, because it is a win exit ticket. 7.5. So go ahead and do that. Again, I should give you just with this, but I'm just nervous with 15 minutes that you guys won't have time to do that win homework check. So go ahead and do that first. When you're done with that, go ahead and work on the worksheet. Like now, yeah, anywhere there's, I mean, I think there's one by the filing cabinet. There's some over here. Wherever you can find one, you're free to move. There's one right back here if you want to sit right here by me. Clear off a spot. I was joking, but if you want to call that bluff, you can. There's one on the other side of that filing cabinet. Number 6. I don't think so. Let me see. Okay, so right here, you have 1 times 2 is positive 2. You have one. That's the hard part about synthetic divisions. You make little mistakes like that. Yes. Yeah, wherever works. You need an X. See how you have the X under the 2, so it'd be 2X. But yes, other than that, perfect.